Today I'll be doing chapter 21, number 73A in our physics notebook. It states the gasoline engine in your car can be modeled as an Otto cycle shown in this figure. A fuel-air mixture is sprayed onto the cylinder at point 1, where the piston is at its farthest distance from the spark plug. The mixture is compressed as the piston moves toward the spark plug during the adiabatic compression stroke. The spark plug fires at point 2, releasing heat energy that can be stored in gasoline. The fuel burns so quickly that the piston doesn't have time to move, so the heating is an isochoric process. The hot, high-pressure gas then pushes the piston out toward the power stroke. Finally, an exhaust valve opens to allow the gas temperature and pressure to drop back to their initial values, starting the cycle all over again. So this is pretty much, that just told you exactly what it's doing. And then the actual problem asks, analyze the Otto cycle and show the work done per cycle is work out equals NR divided by 1 minus gamma, temperature 2 minus temperature 1 plus temperature 4 minus temperature 3. So we're pretty much just going to try to prove this, and we're only going to concentrate on what I have highlighted. So in this whole system, this is the only time where there's heat exchange. So there is heat being taken in from 2 to 3 and heat being released from 4 to 1. So just going to concentrate on that. And because we're just concentrating on that, the work is going to equal the heat in minus the heat out. And the heat in is going to equal to NCV, temperature 3 to minus temperature 2. So the difference in temperature, and then just to remind you guys, we're going from 2 to 3. So the difference is going to be temperature 3 minus temperature 2. And for the heat out, it's going to be NCV, temperature 4 minus temperature 1. And once again, that is the difference in temperature. And then all you do here is just plug everything in. So I plugged everything in, and then I took NCV out, and then you're given this. And then to recall that CV is equal to R minus divided by gamma minus 1. So you get this, and it's almost similar to what we need to get, but not quite. So what you're gonna have to do is take out the negative sign. And then once you take the negative sign out, you plug it back in down here. And then once you do that, you are given this, and that is the answer. So pretty much you just do some algebra to figure out, to prove this equation. And you only use these two processes because these are the only processes in which heat is being exchanged. So that is why we're only using those two. And that is the final answer.